During the month of January, we built a solar thermal hot water kit. The model we built resembles a forced circulation system. Generally, a solar water heater consists of hot water storage tank, a solar collector that absorbs solar energy, and a backup energy source. This type of solar water heater requires a pump to move water from the storage tank to the collector. How does this produce energy? Take the example of a deuterium atom with its proton and neutrons in the nucleus. It takes energy to hold any neutrons together in the nucleus. Let's make up a pretend amount for the quantity of that energy. 3. The actual amount isn't important for the concept. We'll bring in a hydrogen atom since it only has an alone proton and nucleus. There's no energy needed to hold things together. There's only one thing, so the total amount of energy holding stuff together is 3. When the sun fuses these two atoms together, a new type of atom is produced called helium. As you can see, it has 2 protons and 1 neutron, and then its nucleus. The energy needed to keep these atoms together is only 2. But remember, we started out with an amount of energy 3, and now we're using only 2. So where did the extra energy go? In this case, it sped away with this expanding wave called a photon. A photon is an electromagnetic wave that has energy and expands outwards as a large sphere-shaped wave, carrying away our missing energy of the quantity 1. So the total energy is still 3. 2 to hold the new helium atom together, and 1 carried away elsewhere by the photon. But only a small portion of that wave and energy will hit our solar panel on Earth. So we'll illustrate that small portion as this fuzzy wave particle thing. Eventually, the energy in that proton is carried away up through the interior of the sun until finally it emerges. It then makes its way towards Earth to our solar panel for producing energy. The sun gives off 3 different electromagnetic waves: visible light, infrared, and radiation. These forms of energy are different because they do not rely on matter. Falling dominoes resemble conduction because a conductor is an object that can move or conduct heat well as a result of its molecules being close together. Convection currents are an example of heat moving in fluids. The cooler, denser water, as demonstrated by the blue food coloring, moves down as the warmer, lighter water, demonstrated by the red food coloring, moves up. During this motion, the hotter water molecules transfer to the cooler water molecules. During our project, we tested 3 different types of box colors: black, white, and silver. The first run, we tested the black and the white. Both boxes were exposed to the halogen lights, which were used to radiate heat due to the lack of sun for 18 minutes. The final results were 32 and 31. In the next test, we compared the black box and the silver box. We hypothesized that the silver box would win because of the effects of reflection versus the black box's absorption effect. Both boxes were exposed to the halogen lights for 40 minutes. These were the results. The second part of our project, we tested insulation methods. Our first type of insulation was bubble wrap, and our second type of insulation was a layered paper material. We tested both of these for 43 minutes. The bubble wrap rose from 22 to 25, and the paper rose from 21 to 38. The next part of our project, we tested different tubings. We first performed the test on 3 different patterns of tubes. In the end, we chose the 2 circles next to each other because they circulated the water the quickest. We then tested 2 different lengths of tubing, 25 feet and 18 feet. For our final project, we chose the 18-foot because the water was able to travel through the tubing faster. The final part of the tubing test was the difference in diameter, the thicker tubing versus the thinner tubing. For our final project, we chose the thinner tubing because it rose higher than the thicker. Before we produced a final project, we tested 4 different types of tubing materials: copper piping, black rubber, aluminum piping, and clear rubber. The black rubber rose the highest from 20 to 25 in 21 minutes. Had we used any of these materials in our final, we would have chosen the black rubber. In our final project, we chose a silver box with a thin 18-foot tubing and a bucket insulated with a layered paper. Before the test began, we added green food coloring to the water in hopes that the darker color would better absorb the heat radiated from the halogen lights. We also covered our tubing with a clear plastic lid which took advantage of the greenhouse effect. The greenhouse effect is the process of light passing through a clear obstacle and being converted into heat when it hits the interior.